All right. Hello, and welcome to something called Organic Chemistry Shorthand. And I wanted to show you this because when we practice our organic chemistry, you're going to see a lot of things that look like this. And I wanted to explain to you what's going on and what this shape means. So since we're dealing with organic chemistry, we want to take into consideration a couple of points here. One is that organic chemistry deals with carbon. And so anytime we are talking about organic chemistry, we are dealing with carbon and stuff that bonds to carbon. And because organic chemistry deals primarily with carbon, it assumes that all molecules contain carbon. And that means that there's no reason to write out carbon because that's what all these molecules are made of. So what we're looking at here is an organic chemistry molecule, a shorthand molecule for something called propanol. And it's an organic molecule, meaning it's made out of carbon, and it has something called a functional group. In this case, that functional group is called an alcohol, but we're not going to worry about that. What I want to show you is what this squiggly line means, this guy, because that's the shorthand. That's what we're going to deal with here. And we're going to assume one more thing, that if all molecules contain carbon, we're going to assume that all carbons are bonded to hydrogen. And that for the most part, every carbon atom will bond to as many hydrogen atoms as it possibly can. And what that means is, and you guys remember this, that a carbon atom has 4 bonding sites. And that means that when you form a molecule with carbon and you occupy all of the bonding areas, you get sp3 hybridization. And a molecule that is hybridized sp3 is going to have this tetrahedral shape. Okay? Remember, this is what we call sp3 hybridization, and that these angles are 109.5 degrees, so that all of these bond angles are bent, basically. There's no straight lines in a molecule of any organic structure. There are, but we're not going to worry about that for now. So here are some assumptions. Here's what we're going to run with here. In organic chemistry, every molecule contains carbon, and that all carbons are bonded to as many hydrogen atoms as they possibly can. So what we're going to do is we're going to use some shorthand here. Okay? The shorthand is going to look like this. Anytime we have a carbon, we're just going to assume that it's bonded to as many hydrogen atoms as we can. So it doesn't work with this molecule of methane over here because there's only 1 carbon. But let's say we took a molecule of something called ethane. And notice that this consists of 2 carbon atoms, and each atom is bonded to as many hydrogen atoms as possible. In shorthand, organic chemistry doesn't waste any time with drawing all these carbons and hydrogens. That is a molecule of ethane. That's it. That's the shorthand. It's assuming that those 2 are carbon atoms and that they have as many hydrogen atoms as they possibly can have already stuck on them, and we're not going to worry about it. We're just going to assume that that's what that is. So a molecule of something called propane, which looks like this, and it has the formula C3H8. It's called propane. So you burn your grill on the weekends. C3H8. It's got 3 carbons, and each carbon atom has as many hydrogen atoms as it can hold. Remember, these carbon atoms are all hybridized sp3, meaning that all these bond angles are not straight lines. So in organic chemistry shorthand, that's a molecule of propane. Excuse me. That's one too many. All right, that's propane. 1 carbon, 2 carbons, 3 carbons. Okay? Let's do one more, and then I'll show you how this functional group thing works. This is called butane, and there's the formula C4H10. And that means it's got 1, 2, 3, 4 carbon atoms, and each carbon atom automatically has as many hydrogen atoms as it can hold because they're all hybridized sp3. In shorthand, we don't write any of that stuff. 1, 2, 3, 4. That's 1 carbon, 2 carbons, 3 carbons, 4 carbons. And when you start swapping out hydrogens with other groups, other functional groups, we take this name butane, and if we were to stick, for example, say, an alcohol on the end, you'd get, instead of butane, you'd get butanol. And that's shorthand. So when you see something like this, keep in mind that that's 1 carbon, 2 carbon, 3 carbons, and then a functional group. Okay? And that's all organic chemistry shorthand is. So be careful. All right? See you guys on the next one.